Hey guys, how's everything going? This is Jaser. So I've added a new section on my blog, jaser.dev, which is called the Shorts. It's a bit different than the ordinary posts, which is quite some important topics or long paragraphs. For Shorts, it's just some casual topics. Maybe it's just focusing on a small problem, a bad piece of code or something. It's much more short, I would say, so I call it Shorts. So the first short, short. Yeah, I call it short. So the first short today is about a real example of concurrent mode in Shaku. I've mentioned it briefly on my Twitter. Is that I've solved a problem by using the useDeferredValue from concurrent mode, and I thought it would be pretty interesting to show you the power of concurrent mode with this real example from Shaku. So what the problem is? I've mentioned that I've started building this Shaku, like a bunch of tools since this May, and I've launched the Shaku Playground and also the Shaku Snippet. Shaku Playground is just a demo in how powerful the Shaku syntax is, and Shaku Snippet is a small tool that allows you to generate the nice screenshot, download it, and share it to Twitter or anything anywhere else. It supports over 150 languages. So the problem is that when I edited the code before, okay, this product version. I've already improved it, but before, when I just type the code, it shows up instantly, and somehow an error happens. It's called memory allocation error. It inside of this create on scanner or something. It's inside the Shiki parser. So I saw this error because sometimes the syntax highlighting doesn't work. It occurs if I just type it frequently. So it's pretty natural to think that we need to not prevent, handle the frequent key presses, right? This is the original code. I just use the use effect here, and every time when the code changes, we get the processor. This is async, and then for this processor would process the code. This does the natural heavy. This does the actual heavy work. This is pretty heavy, and once it's done, we will update the preview. We hold the preview in a state, and and then we just render the raw HTML, which is the preview on the right. It's pretty obvious, right? But this code has a serious problem, as I said. The memory will be bloated, and actually, the another problem is that the erasing issue. We're not sure that the first process will result in the first preview. Maybe the first one somehow, just like if the code is a lot larger, it costs more time, but the update the code is shorter, so it costs less time, which means that the latter process is done earlier than the first one. So actually, the old data will be put in the preview. So the racing condition is still a problem like this. So how we improve the code is naturally, I think before concurrent, we could just do the debouncing work and also cancel. We would need to cancel the previous one, right? But I don't think the promise could be canceled in this case. If you're requesting some API, you could use the abort control or something. I'm not sure. Maybe we can hack it around, but it's not that easy. Anyway, the first idea I tried to improve is just to debounce on it. You can see the changes here. Before we're using the effect, we're still using the effect, but inside of it, we use a debounce to render function, which is the use debounced callback. This is a general use debounced callback. And then inside the use effect, we just call the debounced version of the render. So every time the code changes, this will add a cooldown time. Like I said, like to 1 second here. So after this, the error is gone. Obviously, it's pretty cool. But there's a huge UX problem, and also still the racing problem still exist, right? We didn't solve the racing issue. Let's take a look at the improved version. You can see that when I type here, like the question mark, you can see that there's series lag, right? Series lag in the preview, both when I update the code and also select a different language. This is because we're setting a fixed timeout in 1 second or 1000 millisecond. The problem is that for a high-spec machine, like actually I am having, which is, while it's not the latest model, it's M1, it's so powerful. So actually, we don't need the delay here. We can actually serve the preview pretty instantly. We're here merely solving the memory issue, but we are generating bad UX as a side effect. From the UX side, it's even worse than the first one, original one. So how will we solve this issue? Well, this is where the concurrent mode kicks in. I've explained how useDeferredValue works. It's pretty powerful. The general idea, you can simply put useDeferredValue changes makes the change of the data into a low priority update, so it could be interrupted by other high priority tasks. Yeah, this is just concurrent mode stuff. So this, I've changed the code into something like this. Yeah, for this to work, actually we need to because we need to use the suspense, because for the useDeferredValue to work, we need to which is lazily initialize the fetcher stuff. In our code, there were two async functions, right? The first one is get processor and then process. Both of them are async. So we need two stores here. This is a general fetcher. Maybe it's not good enough, but it works. I've explained this piece of code like for a lot of times. Please go to like my blog to search for the explanation. So here, this is the get processor, and simply when we get a process for a specific language, if it's already there, we just use it. If not, we create a fetcher to fetch it, and so you can see that this is only initialized for once. And also for the process result store, it's the same, except that it has two parameters. Like the first one is language, and the second one is code. We just put them in one string as the key. So now, if this pair of the code, I really wish that the spec for native support for the not tuple, what is that, tuple or something? Yeah, could come earlier. Anyway, if it is not processed yet, we start the process. Yeah, here we get the fetcher, and actually inside of it, we just call the process to process. The process here, because in our use code here, process, when we get the process result, the process must be there already, so we don't need to worry about it. Otherwise, we need some extra hack here. Anyway, so you can see that we remove this bunch of code, like really hacky, and make it into some code like looks asynchronous, right? Here is important. We need to use the deferred value, and here also use the deferred value, language, code, and then we get the processor of deferred language, and then we process the deferred code like this. And here's the final result. We could take a look. So here, when we type the question mark like this, you can see that the preview updates instantly. Even if we change the language, it also updates pretty fast, right? Yeah. So we succeeded in changing the fixed delay into some like a delay based on the machine spec. If it is high spec, the delay could naturally be small. But if it is like it's slow machine, the delay might be bigger. Here's my thoughts about what is going on here. Because I've already understand the basics of the internals, I didn't spend my time diving into the actual code in our case, but I think I'm right about this. So if the key presses are sparse, like I type it, waiting for a lot of time, and I type again, the original approach and last approach are actually the same because the whole rendering process, including the process thing and also the React thing, they are pretty quick, so you won't notice any like a lag thing. Yeah, the only problem is that if the key presses are dense, like I press the key frequently, and in our original code, we're putting the render in the useEffect callback. But useEffect callback is for React, it's just some random callback. It doesn't know anything about the callback. It could be anything, right? It could be a side effect, or you're scheduling a re-render. React doesn't know. So what it does is that, because the process work, the parsing, the markdown, the syntax thing is heavy, so it will block the main thread. So during that time, if we type it a little, press the key a lot, React just stacks the updates and the effect callback as well, stacks it, and later they all will be flushed. Right? They'll be all flushed, and use effect callback will always be run, so there will be multiple of them and thus bloat the browser. But in our last implementation in the concurrent mode, things are a bit different, because React knows that every time you're scheduling a re-render, not the use effect, some random callback. So in this case, I've already mentioned before, like about the transition. Here is a very important, is that if there's already a callback node, you cancel the callback. So if a render is not done and we reschedule a new one, the old one is actually going to be canceled. So this is how interruption happens. This means that even though the browser is busy right now, we are scheduling the work in the concurrent mode. We're scheduling in the current mode, and if we have multiple of them, only the last one will be kept. The ones before it will just be ignored, because their callback, the eventual goal is actually the same. It's just to re-render the whole app. So React knows that we can just somehow internally debounce that. Internal debounce, yeah. Oh, great word. So you might be still a little vague about what it happens under the hood. So think about this: if you're staying at the restaurant, and the waiter just accept the orders, you just kept asking the waiter to update your orders, right? And once the order is being prepared in the kitchen, it is heavy work. The waiter may not be responsive because you need to be careful, look at the chef or something. So if you're putting the request, like to update the order in the use effect, the waiter will just stack all the orders, because he doesn't know the orders are from you. Like I said, it's some random task. He just accepts random orders. He doesn't check the where it is from. So you will send all the orders to the kitchen. Obviously, if there's long enough, it will stack a lot of orders. The kitchen will bloat, right? It will be on fire. But if under concurrent mode, waiter knows that his goal is not to just accept like random orders, random tasks. His job is to make sure that each table has their order updated. So this is his job. So this time, even if the kitchen is preparing the food for everybody, it's busy. If you requested multiple times to update your order, the waiter knows that for each table, he could just keep the last order. So no matter how many times you ask, only the last order will be sent to the kitchen. So now the kitchen is saved. Everyone is happy. This is why the concurrent mode is good, because of the interruption. The work is interruptible. Yeah, that's it. And naturally, you could see that how this approach prevents the racing issue, right? There won't be, because every time re-render, the waiter only accepts the latest order. Yeah, so I think that's it. I need to point out that it doesn't mean that the this won't like bloat or anything. You must be careful about the interval, how you can handle the work. So there's still a chance that it will bloat, but the chance is much lower right now, I think. Great. I think that's it. Hope it helps. Yeah. See you next time. Bye.